Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in the series of data structures and algorithms, we will see how to implement the method insert on the doubly linked list. So we have seen adding an element at the beginning of the linked list, doubly linked list, and at the end of the doubly linked list using the append and prepend methods. Now, if you wanted to insert an element at the middle of the doubly linked list, how to do that? So that method that we will see today. So now let's understand what operations that we need to do or we need to perform in that insert method. So now this is the doubly linked list. Now if you want, like we have seen how prepend works, right? Like if you wanted to insert one element at the head, then what we have done to that new node, what we have moved that head, and the next is uh, pass it to the the next pointer is pointed to the current head and the previous is pointed to the none. So like that we have added the append method, sorry, prepend method. So append method means that will insert an element at the end of the doubly linked list. For that what we have done, we have created a new node and the tail pointer we have moved, and then this to be pointed to the none, and then this previous was pointing to this one, right? So this previous already I have marked. So this is the append method. Now let's see how to insert an element at the middle, some given position, at the given position in the doubly linked list. Now let's try to insert one node called 8 somewhere between 2 and 3. So in this place we wanted to insert a new node called 8 between 2 and 3. So when you wanted to insert, right, based on the position like 0, 1, 2 in the second position, you wanted to insert this. So some cases like we always do, right, in using the edge cases that we usually consider. First one is whatever the index that we are passing should be like greater than 0 and within the length. And in case if we are passing the index or position as 0, then it should prepend the value to this list, because prepend is what it does for inserting a new node, right? Prepending a new node at the beginning of the list. And in case the index or position that we are giving is same as the length, means at the end we wanted to append the value. Now after, like, these are the corner cases. Now let's say it's a normal insert method where you wanted to insert the value somewhere in the middle of the doubly linked list. That time how we have to do? So first thing is, now because this is where you wanted to have that the element to be inserted, right? So now we will consider these 2 as before and 3 as after. Okay, right? So now why we are taking that? 2 is before and 3 is after. Now currently these are the 2 arrows that are pointing in between these 2 nodes, and we have 8 here. So now what we have to do? This particular pointer should be pointing to this, and this particular pointer should be pointing to this newly created node. Now how can we get before and after to this? Is we have the new node as 8, right? We do you remember we had worked on get method? So using the get, and here we have the index, using the index -1 we can get the value or element of the previous to the new node. So that's how we will consider which one is the before value. And for getting the after, we can simply say before dot next. That way we can get the after value, I mean after node, so that we can get what is the before node and what is the after node. Now we have everything. Now these two are the like the pointers that are pointing between these two. So now what to do? First one is we have the new node here, right? From the new node dot previous equal to before we have to point that, and new node dot next equal to after. Fine, right? Now what is this? Before dot next to be pointed to the new node, and this after dot previous is pointing to the new node. So now what happens? From 2, this this pointer is going this way and this pointer is going this way. So now let's take this new node equal to node of data. Now as I said, we have before, right? Before, how we have achieved this is we have called the self.get method and position -1. Okay, fine, right? It's clear. So because whatever position that we wanted to insert, just -1 will give us the before node. Now we have to get the after node as well. So after is equal to, simply we can put before dot next. Now we have given the before and after pointers, but we have to insert this 8 between 2 and 3. So for that, what we have done as a first step is, first we have taken this new node and new node dot previous equal to before. So that assignment we have done. Now let's do that. New node equal to new node dot previous. We are pointing the previous pointer to before, right? And new node dot after, not after, next, right? New node dot next equal to after. Okay, this is how we can just connect it from the new node to these two nodes. But now in between these two are there, no? That also we have to point to this newly created node. So before dot next equal to new node and after dot previous equal to new node. Got it, right? Now let's execute that in the Python online compiler. Let it come, and let's take the, like, till the previous lecture we have taken this, we have created this entire class, right? Let me copy that entire thing. So it has all the append, prepend and everything. So now when I run this, it is having 5 elements, 1 2 3 4 5 to none. Now let's write the code here. Fine, let's write the code for which one is this? Insert element something. Okay, self comma, we have to pass the position, or even we can say index comma data. Both the things we have to pass. I mean, in which index you wanted to insert and what is the value that you wanted to give for that node. Now first we discussed about the edge cases, right? So if index is less than 0 or index is greater than self dot length, which is like it's not in the range of the doubly linked list, then we will say return false. So here you can clearly mention the, if like loggers, you can enable the loggers and say please enter the index which is positive value or which is within the limit. You can just mention that kind of the print statements. Now let's say if index equal to 0, so which is the prepend method, right? Then we can say we have this prepend method created with the in one of the, like one of the videos. So you can go through that if you are not already done. Now we'll say return prepend of data, right? Got it? Now if index equal to self dot length, right? Let's say there are 5 elements in this, right? 0 1 2 3 like 1 2 4 elements are there, and you are mentioning 4 as the position that you wanted to insert, then it is actually at the end of the linked list, right? So that is why we are checking if the index is equal to length, and length plus 1 also you can mention in case you are like working from starting with 0 instead of starting with 0. If you are trying with 1, right, that time you can have length plus 1 as well. So it's based on how you are taking the length value or even the index value. So in that case, what we have to do, return append of data. So here this is the function that we have here, append value. So these are all the class methods, right? We should use the self dot prepend and self dot append method. Okay, now comes to the original code. Like instead of now, just now we coded for the corner cases. Now let's create the new node. So node of data, this will create the new node. Now what we have to do, we have to assign the before and after pointer, which we have just now we have done here, right? The same thing. Okay, so what we have done is before self dot get, there is a get node. Okay, fine, get underscore node of index minus 1. Okay, now what it will give, it will give the, like for example, if we are sending the index as 2, it gives 1. So 1 means that whatever is the before that we wanted to insert. Now let how the after is calculated is before is there, now before dot next. Now for example 2 is before, then before dot next will become 3. Now let's give assign the pointers for that, like new node to the previous, and next we will assign previous as before and dot next as after. And similarly for the in between 2 and 3 there are already this backward and forward pointers are already established, right? So that we will point to the new node. Okay, then this is how we will say, and we will say return true. Now we have this. Now let's say dll dot, what is the function name, insert element at the position 2, right? 0 1 0 1 1, first position 8 is what we have to insert, and after that we will say print the list. Now we also have to increase the length to 1. Now let's run the code. So we are calling this insert element method, and I have just added the print statement, and I also added the what data in which index we wanted to print. Now 0 1, so in the first index we wanted to print this. Now if we wanted to print between the 2 and 3, then let's run this. Now in the second position we wanted to insert the 8, so 0 1 2, in the second position we wanted to insert 8 value. Okay, now this is how we can implement the insert element method. Now talking about the time complexity and space complexity of this, right? Now we have to traverse like it to starting from head, we have to traverse through the tail method until we found that position, right? So again here if you take the best case, the starting itself you wanted to insert the data, then it will become order of 1. But in case if you have to just traverse till the last position of this, then the time complexity is order of n. And similarly here coming to the space complexity, right? Here almost every fixed amount of memory is allocated to each node, right? So space complexity of insert method in doubly linked list is order of 1. Okay, time complexity is order of n and space complexity is order of 1. Okay, hope this is useful for you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.